Okay, fine. So that's fine. So thank you, Dali. Thank you. Yeah. So next, Harvinder.
Yeah, hi everyone. So this is Harvinder Singh. So I'm having around 9 years of experience, and the Kafka has been there, and for asynchronous communication we are using. I just want to know what are the other use cases are there, like as a log aggregator, streaming APIs, streaming apps are right now popular. So how they are using and managing the millions of data with that. So that is the whole purpose of joining this course.
Okay, that's fine. Yeah. So thank you, Harvinder. Thank you. So next, please. Yeah. I think in my side only I'll be calling Harvinder. So for Harvinder, I think Joshu or else Lagbir Singh. Yeah.
Yeah, hi, I'm Lagbir. So I have around 12 plus years of experience. So I'm right now working as a technical architect. So basically, I've been using this Kafka from past 7 years, more than past 7 years. So so basically, I'm actively using Kafka in day-to-day activity, and it is like an avoidable component in system design also. So basically, my intent of joining this course would be more diverse experience on Kafka streams, K table, and also Kafka in terms of like analytics, use cases in analytics also. And apart from that, some like insight working of the Kafka itself. So and more diversified use cases. So this would be my intent to join this Kafka itself. Yeah, this Kafka course itself. Yeah. So thank you.
Yeah. Thank you. Thank you. Thank you for this, Lapi. So yeah. And please, next, I think
Hello, I'm
Joshu.
Madhav. I have
Yeah,
total
please.
10 years of experience. I'm working as a project lead. Actually, I didn't get chance to work on the Kafka, so I thought that I will learn this. That's why I joined the class. Am I audible?
Yes, yes, yeah. You're audible. Thank you. Thank you for this. Thank you. Thank you. Yeah. So next, please. Yeah. Uh, I think Rehan Qureshi. Rehan Qureshi. Some other one? Is it audible, right? Everyone? Hello? You're Rehan Qureshi. Sorry. Okay. Fine. Can't talk traveling. So, okay. It's okay. Fine. So, Joshu, I think you did. Satish. Yeah.
Yeah, I'm a 4 year Java developer. So inside my project, there is a Kafka feature. So I'm new for that. That's why I joined it. Yes.
Sorry. Think we hadn't heard about that. So, can you please come again?
Yeah, I'm audible now.
Yeah, you're audible. Yeah.
Yeah, I have 4 year experience. I'm new in Kafka.
Mhm.
So I don't know that much is Kafka. Only producer consumer like working and message queue in a Kafka and ZooKeeper as a use inside that. But I don't know details of how the working the consumer group partitions, how the offset is, how they're working as perspective developer. So that's why I joined this class.
Perfect. Yeah. So, I think anyone we missed it? I feel I think we are done with everyone, I think, right? Okay, quick. Last but least from my end. So before that. So is it my screen is visible, right? Is it my screen is visible?
Yes. Yep.
Is it fine, right? Yeah. So quickly about my introduction. So I'm Veer. So I'm having like overall 14 plus years of experience in this IT domain. So currently I work as a principal cybersecurity engineer. So in one of the bank Australian bank company. So that is my experience. And again, meanwhile, I used to work with the different domains. So and again, meanwhile, have a 9 years of experience in the training sectors also. So I used to train basic apps, ML apps, and again all this cybersecurity stuff like application security, cloud security, network security, many more, right? And also completely this event-driven architectures, how we need to implement. So all these kind of activities. So this is what like my quick intro. And not only implementing this event-driven architecture in my companies, I need to analyze how high availability, disaster recovery, how we need to take the backups. So this is what design I need to implement, and again need to participate for this configuration, and again with automation way. That is what my previous roles and again current role setups. Now, apart from this, I need to do the architecture setup also for the security areas. So those are the areas I used to work now currently. So yeah, so this is my quick intro. Meanwhile, so why this Kafka? Everyone knows that message queuing services. We have many open queuing, message queuing services like RabbitMQ, and again Microsoft message queuing services, and again many more tools, and again RabbitMQ also, right? So why this Apache Kafka? Why we require this Kafka? So everyone knows that already we are working in these areas. We need to understand but basically what I'm going to cover here. So first thing, how to set up a Kubernetes. So how to set up a Kafka architecture. And again, meanwhile, that Kafka architecture should be in the monolithic wise, either with microservices wise, right? So, but everyone knows that how to set up a Kafka architecture, how to create a Kafka cluster, and again, how to make it out this, or else just as a end user in a company you guys are using.
First question, sir. Why we need Apache Kafka, like Kafka solution in application? What kind of problem required is?
Yeah, exactly. Is it audible, right? So, hello.
Yes.
It's basically event-driven architecture, right? Event-driven architecture. What is this event-driven architecture? So before taking that big new terminologies, we need to understand what is this message queuing services. Then again, we'll come back to the Kafka architecture. Clear, right? So what is message queuing services? Any idea?
So there's IBM MQs, like where we are async communications, like we are keeping message, adding, and then at the other end, somebody reading and then removing that messages, that events from queue.
Okay. That is one of the main reason. But rather than sending the message queuing services like one by one, right? I mean, like at a time, we cannot able to do that activities, right? So that's why we require a through the pipeline where I can send the messages. Like that is what queue various. So for that purpose, we require a queuing services. So, but now when there is a RabbitMQ, when there is a Microsoft message queuing services, why we require this Kafka? What does it makes more beneficial rather than RabbitMQ and again Microsoft message queuing services? Because many of them heard about RabbitMQ, but there's a few less people heard about Microsoft message queuing services. Those are the Microsoft message queuing services. We will be using those stuff only in the Microsoft products, like example .NET frameworks. But in this case, why Kafka? Anyone?
So basically, Kafka is less memory intensive and it is more performant, and moreover, like it tend to store the entire. It automatically backups the messages in the form of partition on the hard disk itself. So all over, it is much more performance system. It give more throughput as compared to RabbitMQ. So like if the system do scale, if the event do increases more than millions or billions, even trillions, so it can handle easily as compared to RabbitMQ, where it do have a upper threshold. It directly proportionate to its memory consumption as compared to Kafka itself. So I believe, yeah, that's what lead to its popularity itself due to its performance.
Yeah, so perfect, like that. Like what you said, that is a true points. But addition in those points, I need to add like a few more points, right? So the first one, it is a mainly distributed and it is a scalable. That is one of the main point we need to understand. It is a distributed, scalable. How it is distributed, how it is scalable. So that's what the architecture it shows. Broker one, broker two, broker three, and again replication factors of broker one, broker two, broker three. That is a distributed way, and again the scalable. Even if we want additional brokers, we can have the new broker. That is a For this terminology, distributed and again scalable, that is one of the main point. In RabbitMQ, in Microsoft Message Queuing, or else Apache Pulsar, they doesn't have this distributed and again scalable way. So that's why this Apache Kafka is a main point we need to understand. This is a distributed and again scalable way. Again, one more point, one of the important, why Kafka is into the picture when there is a multiple message queuing services. The first point is performance, everything is fine. But the main thing is distributed and again scalable. Because see, right now in our existing architecture, if we have a broker one, broker two, broker three, so I can add more brokers and again I can do more replication factors. So that's why it is a scalable and again distributed wise. That is the first point. And again, the second point, we can also make that I through output. So what is this I through output in the sense? Compared to any message queuing services, the messages can be streamed like milliseconds rather than milliseconds, nanoseconds. It will be streamed. So that is one of the main thing, because even though nowadays we can use like Ola Maps, Uber app maps, and again Netflix streaming logs, and again banking transactions, right? And again IoT data, many more, and again blockchain data, and again trading application data, right? So those we require in nanoseconds wise transactions. For that, very high through output compared to all the things. Clear, right? That is one of the thing. So distributed and again scalable wise. And again, the second point, we can also discuss that I through output. And again, data persistency. Compared to any messaging queuing services, data persistence will be somewhere it is be broken areas. But in this Kafka, it is a more persistence. So that is one of the thing. And again, what is the data persistence here? So the retention days, like 7 days or might be 20 days, might be 30 days will be the retention days. Right? So data persistence. So is it clear, Bhavani, for this your point? Data persistence and again fault tolerance. See, this fault tolerance will be available in the all the message queuing services. But the same thing, it is also included here. But the three things we need to remember, that data persistence with the retention period, and again also distributed and again scalable way, and again also very high through output. There is a more three important points, right? And of course, all the message queuing services will be doing the real-time streaming, even if you includes Apache Spark, Apache Flink, and again Kafka streams, right? So it is a real-time streaming equivalent to all the message queuing services. But now, one of the very important point compared to any other message queuing services, including Apache Pulsar also latest one. But here, multiple consumers can read at a time the same data, right? That is one of the main plus point. Like consumer groups we can create, consumer group 2 we can create. So multiple consumer groups we can create, and again each group can read the same data at a time. So that is one of the main point, right? So we can, is it clear, right? So I can write the points also here. So in these classes, in my classes, we are going to learn how to create a Apache Kafka cluster in monolithic application wise and again microservices application wise. What is this monolithic application wise? In the sense, we need to create a servers in Windows and again Linux, both the operating system platform. We need to set up the Kubernetes, we need to set the Kafka cluster setup. And again, after that, we need to use Docker files. And again, the Docker files means nothing but Docker images. We need to create the Docker images. And again, we need to support as a microservices based. That is one of the thing. Okay. So why Kafka? Why Kafka is a simple question for everyone. Okay. Why Kafka compared to any other message queuing services? Message queuing services. Of course, because all we are having a great experience, more than 8+ years of experience, right? So for that, we need to drive into next level, architect level, and again principal roles level, right? So that's why we don't want to understand the basic inputs level. We need to understand the master level of how to do setups, how to do security for the Kafka cluster, and again how to make replication factors with high availability, and again with the disaster recovery, and again without any downtime of data streaming. That's the main points. These are the 3 to 4 points we are going to discuss in our classes. Right. So why Kafka compared to any other messages? On top of that, Lagbir, whatever he said, the same things, but still we need to have these points. Once again, what is the first point? I can forward that. What is the first point? Data streaming, data performance, persistence. Data persistence is one of the main important thing here, including we need to design that including data retentions, including retention days. One of the thing. And again, next one, this is a distributor, right? Distributor, and again, scalable. And again, also very important point, very high, what I can say, very high through output. Very high throughput. So what is this very high through output? Is nothing but partition-based architecture, and either it might be sequential disk writings method, any kind of activities. And again, fault tolerance will be available for all the message queuing services. And also one of the major point, real-time streaming. Compared to any this real-time streaming, all the message queuing services, but compared to Spark and again Kafka streams, it is very important in this case, real-time streaming. But at the time, multiple consumers at a time, like, multiple consumers can read same data. Right? And again, it is designed for mainly that event streaming. The name itself, it says events. Whatever we do, that events. Even if you log into the application, even if I do any order, so that events will be taken care here. So that's what, like, event streaming. This is one of the major important points compared to any other message queuing services. Clear, right?
Is there any difference, sir, between the real-time streaming and event streaming?
No, it's the same area only. Real-time streaming, see, real-time streamings are nothing but, like, take an example now, Google App Maps, right? When we are traveling in the Ola, so each time the real-time streaming will be happening. But events, what is the main difference? So it's a good question, actually, Bhavani. Thank you for this. See, real-time streaming, it is a live application tracking, but event means once, like, if I reach from one block to other block, that event will be captured. That event is same areas only, but this event will take, like, millisecond to delay for that output. That's the same thing. Clear, Bhavani? Yeah.
What is the difference between Apache Kafka and Apache Pulsar?
See, sorry.
What is the difference between Apache Kafka and Apache Pulsar?
Okay. So in this case, have you anytime worked in Pulsar?
In my application, Pulsar was there, so I gone
Yes.
some.
So generally, we know that Kafka is nothing but it is a distributed event streaming platform, right? But what is a Pulsar? Here, what is in the streaming areas? In the Pulsar areas, we have brokers for serving clients. We have a bookkeepers. But in this case, we have a bookers. But here in the Kafka, we doesn't have a bookers. So that's the main thing. That's it. But here in the Pulsar, we have a multi-tenancy and again geo replications. But in Kafka, we don't have that options. That's the main difference. That's it. The same areas only, but main thing, the characteristics for the Kafka, like, example, brokers requires us to store the data here, producers, consumers, and again topics and again partitions in the Kafka. But in the Pulsar, we have a brokers for serving clients and again multi-tenancy and again geo replications. That's the main difference.
Okay.
But Pulsar we use, like, especially for the separate compute and again separate storage areas. But it is an independent scaling. But here scalable by adding the brokers in the Kafka level. But in the Pulsar, we have a built-in method. So that's one of the things. But still, many companies we use Kafka and again ZooKeeper only, but only the few companies we use for Pulsar. But we migrated for the few replications factors, few data streaming into the Kafka to the Pulsar areas. Why Pulsar is required compared to Kafka in the sense, it's a more speeder performance, geo replication based. That's one thing. We'll do that lab. The last moment, I'll show that migration activities, how to do from the Kafka areas to this area. Is it clear, Madhav?
Yeah. Okay. Thank you.
Okay. But we require, like, more patience for that, for setup of the Apache Pulsar, because everyone knows Kafka and ZooKeeper. Pulsar is a very important for in the right now in the market. It is also equivalent to Kafka ZooKeeper, but only for the few companies we use Pulsar. Where we use Pulsar exactly? In the banking applications, because we have a n number of data streamings will be available, many applications. So at that time we use this kind of pulsar areas. Okay. Is it clear, right? Can I move to the next step?
Yeah, it is clear.
Okay, this is why Kafka we required. And also, meanwhile, we can understand. I think everyone knows this architecture, right? Everyone knows this architecture. Also, we know that what is a producer, what is a topic, what is a partition, what is a broker, what is a ZooKeeper. But right now, in the latest version for the Kafka, we don't have a ZooKeeper. We have a craft mode. Okay, but still we can also use the ZooKeeper, but we can also use the craft mode both.
Can you please explain briefly about this terminology, producer, topic, partition, broker, replica?
Sure, definitely. So all these things, okay, I'll be writing these topics here, basically. What we are going to learn, have a syllabus copy also, I'll be sending that. But meanwhile, so as per this terminologies and again components, we need to understand in depth. So because components, terminologies are very important point. Okay. First thing I'll be writing here. Today and tomorrow, demo classes. Setting up Kafka architecture.
Will we get recording after enroll?
Sorry?
Will we get recording of classes?
Yeah, we will be getting the recording classes. Yeah, definitely.
Okay.
Kafka cluster with high availability. So setting of Kafka cluster with single broker and again multi brokers. Setting of Kafka cluster with single broker and multi brokers. Multi brokers. This is what high availability. And again next. Understanding the architecture. And again blocks. Understand the deep terminologies and components of Kafka. Kafka and again ZooKeeper. Is it clear, right? Okay, so now quickly we'll write some points, basically understanding, right? What is a Kafka? Generally, we know that Kafka is nothing but distributed, right? So basically, we can say distributed event streaming platform. It is used to send, store, and process large amount of data, generally real-time data. Is it clear, right? So, and also while doing the setups, I missed your first point. Here we are going to set up self-managed Kafka cluster, and again microservices based, and again AWS MSK. If we have a time limit, we can also use Google Cloud PubSub. Do everyone is having a Google Cloud account? Hello, yeah. Anyway, so now in this case, so first thing we need to understand what is a producer. Any idea about producers? Producers.
Any source which is creating message or copying message?
Yeah, simply we can sense application, right? Application that sends data, right? Or messages to Kafka. So those applications are nothing but either web applications, either mobile applications, either any kind of data sources. Example, right? Next, consumer. What is the consumer here? But we need to integrate producer to the Kafka. This is a very important point. How to integrate this, we can see in the lab. Next, what is the consumer?
Database.
Application that reads data from Kafka. Producers, application that sends data or messages to Kafka. Like example, web applications or any kind of applications. Okay, that's one thing. Next, consumer, where it consumes the data, right? Application that reads data from the Kafka. Then what is a broker? What is a broker? Any idea? I think many of them are working in the same areas, right? What is a broker? We are writing the
Group,
sir.
Broker is a message queue.
Yeah, Kafka is a Kafka components. Generally, I can say these are Kafka components. Broker.
Sir, the producer and consumer are not part of Kafka component. Like they are the external things.
Yeah, those are external areas. Those are external areas. But still, we use the same components like in the Kafka level. That's it. Yeah, next. What is a broker here? It is a Kafka server, right? It is a Kafka server. It is a main component, right? It is a Kafka server that stores and manages messages. This is important. Brokers, might be one broker, might be 100 brokers, might be n number of brokers. Next topic. We'll draw the architecture also after this. What is the topic? It is a channel, right? It is a very important area. Topic is very important. Without topic, we cannot able to send the or else store the message in the broker areas. Topic. What is the topic? I will give the hints. It's a channel. It's a channel where messages are stored, right? And again, partitions. What are the partitions here? Any idea? See, topic is a channel where we can store the messages, but partitions is nothing but splitting the topics. Correct, right? Okay. So what is the partitions here? Like each topic will split into partitions for scalability. This is important. What is a partition? Each topic, if I create 100 topics, take one topic, each topic can be splitting into the partitions. So these partitions will be for the scalability performance. Clear, right? Then again, consumers. Consumers, collection of consumers is called as a consumer group. Also, we call it as a consumer group. And again, consumers, this one, I can write it two areas. Consumers group. Consumers and again, consumer group. Collection of consumers is called as a consumer group. We can create a number of consumer groups also. Okay, so what is this consumer group? Why we require these consumers? Consumers will read the same data. Clear, right? Are we understanding any confusions here?
Yes, I just got confused between broker and topic. So broker used to store message, and then topic again we are using.
See, it is a channel where messages are stored, but it is a broker is a server. Without this server, we cannot able to store directly, right? So that's why we require a topic.
So inside broker is topic, inside topic there is a broker.
Inside a broker, there is a topics. Clear, right? Is it clear? Okay. So it is a group, consumers reading the same topic, consumers group. Then what is a Kafka cluster? First thing, what is a Kafka cluster? What is a Kafka cluster?
Number of brokers.
Collection of multiple brokers. Simple area. Collection of multiple brokers. Then messages are event. Both the same. What is this? There's nothing but actual data sent to Kafka. Offset, it is one of the very important area. What is offset? What is offset?
Index of messages.
Exactly. We can also tell in the other way. It is a unique ID for each messages. Index numbers, we can tell. That is also one point. Also, we can tell that unique ID. Unique ID for each messages in your partitions. Clear? These are components generally. Broker, topic, partitions, consumer groups, Kafka cluster, message event, right? And again, offset. Right. Any confusion still now?
Can you say offset as a primary key, like in database? Can you
Yeah, we can tell primary key. Yeah.
Okay.
Primary key. We can say, yeah.
Okay, thank you.
Yeah, because this Kafka cluster, we should learn in the, I think everyone knows Kubernetes also, right? Kubernetes.
Having the basic idea, not work, no?
Okay. The same components we do have there also. The same components here. Right. So now I need to understand first area we can take it out, consumer part. Then we'll go with producer part. Then we'll go with Kafka cluster areas. Okay. Okay. Or else we'll take with the Kafka cluster terminologies, basically. Okay. So we know what is controller, and again we know what is leader election, and we know what is metadata, and we know what is rack awareness, everything, right? These are Kafka cluster terminologies. And again, finally, we need ZooKeeper. Okay, we'll take the ZooKeeper later part. And we can also, okay, we can give the Kafka internal terminologies. In this case, we know what is record, what is key, what is value, what is producer API, what is consumer API. All we know, I think. Replications, what is replications? What is replications? What is replications? What is replica? And again, leader, follower. These are the important terminologies in the Kafka internal terminologies, okay? Follower. And again, one of the very important stuff we need to understand, in sync. In sync replica. Then again, retentions. Then again, logs, log segments. Fine. And again, also we need to understand some of the batchings, compressions. That's it. Like many more will be there. So what I remember, I am noting here. And we need to understand one of the main point, partitions, topic and again partitions. Topic and partitions terminologies, we need to understand what is a partition key, what is a partition offset, and again, what is a round robin, we need to understand. And again, sticky partition. Any, have you heard about all these of terminologies? I feel like
No.
Dot is working in the consumer areas like partition key, partition offset, round robin, sticky partitions. What is a round robin? It is a method of distributing the messages like across the same multiple partitions. If it is a sticky partition is important because it will be keep sending the messages to the same partition temporarily. So because we need sometimes for temporarily data should be processed. Then again, what is a partition key?
So basically, we do provide a key while publishing a message, right? So
Yeah.
it got serialized and hashed also. So after hashing, it got indexed and assigned some partition to it. So the Kafka or the master broker do assign some partition to that. Based on that, like sometimes we only provide the same key, so automatically it will go hash to the same value, then automatically it will go to the same partition, so the load balance will not going to, so basically it will not going to perform, not going to give the high throughput, so automatically one consumer will going to do the entire activity in this case. So the partition key help us in load balancing the entire system.
Perfect. So we can tell like this, which determines the partition to store the data. Perfect. Yeah, same thing. So now this is one thing, topic and again partitions. Now, very important point, consumers. Consumer terminologies I can introduce here. Consumer terminologies are nothing but Dolly, like any terminologies if you remember, can you please tell me that? Consumer terminologies. Basically, you work in consumers, right? So that's why. Consumer poll, consumer lag. Consumer poll is nothing but what is this exactly? It will be fetching the messages from the same Kafka, right? Lag is nothing but consumer lag. It will be the delay between produced and again consumed messages. And one of the very important rebalancing and again auto commit and also manual commit. We'll see when we use auto commit, when we use manual commit, everything. Then Kafka internal topics, Kafka cluster terminologies. This is fine. No. So one of the very important point I need to note out here, security terminologies. So we know that TLS generally, and also we know that SASL, like authentication mechanism, encryption for Kafka communications, like TLS, and again this SASL, and access control list for the specific topics, right? So access control list we can use for the specific topics to read, to write, to execute like this. And again, Kerberos authentication method. Anyway, these are older. So from here, it is a older. If it is in data center, Kafka, and again, ZooKeeper data center in the on-premises data center, still we use the Kerberos authentications, and also we use encryptions, basic encryptions method. Okay, right? Now, deployment. deployment terminologies. What is the deployment terminologies here? We have like standalone Kafka. We have distributed Kafka. And again, we have a managed Kafka. Managed Kafka in AWS or any cloud provider. And again, finally, care-of mode. So we can also create a standalone Kafka, multi-brokers Kafka with both Windows operating system and again Linux operating system. And again, we can also use the AWS managed streaming platforms like AWS Kinesis and again AWS MSK, both. Clear, right? Overall, very important terms. Overall, very important terms. What is this exactly? Producer, consumer, broker, topic, partition, offset, same thing. Consumer group, replications, then again, leaders and follower. Both are same only. Last but least, Kafka cluster. Is it clear, right? Any confusion still now? Any confusions here?
No.
Okay. Okay. So everyone is having a AWS cloud account, right? Everyone is having AWS cloud account.
I did have, but need to check that it might got expired. Yeah.
Okay. Fine. So can you please log into the AWS cloud account? Can you please check that?
Yeah,
Once
I'm
again.
checking. I'm checking my AWS account.
Yeah, yes, please. Sorry. Yeah. I'm also checking my other credentials. Once again, I'm logging into this. Okay, if it is not, just I'm checking. Once again, I'm checking into the login of AWS cloud account.
अच्छा ये क्लास है 5 बजे अनन्या आज वो हमारा ये जो लिंक करा नहीं क्या हैं? नहीं बहुत बढ़ गया था
I'll be logging into my root account. I'll be logging to this. So should we need to learn from the cluster creation setup, or else directly we can go to the advanced areas? How you guys will feel if everything goes well in the classes? Hello? Hello, is it audible, right, everyone? Are we there? Hello?
Yeah, I believe we can go for this basic concepts first, then we can move to the advanced. So we can cover the basic concept fast, and then we can move to the advanced concepts. Yeah.
Okay, we can move to the advanced concepts then. Okay, so first we need to set up the Kubernetes. So what is it? Kafka cluster setups. Then again, we need to move on this areas. Okay, I got some message. Let me check. Start from scratch, please, or from cluster setup. Okay, yeah. So because that cluster setup is in the three modes. Cluster setup is in the three modes, whether in the standalone with the self-managed or else in the different areas. I think I don't have AWS Cloud Account access here once again. Anyone is having AWS Cloud Account access? Hello. So quick, okay, I'll read this architecture quickly. So I think the same architecture, even if I draw the same thing only. So producer, like nothing but application that sends the data to the Kafka. Topic, it's a channel, and you can partition it as a subdivision for topics. So everything will comes inside the broker only, okay? So cluster, what is a cluster? Kafka cluster is a collection of multiple brokers. And again, inside the broker, we have a topics. Inside the topics, we have a multiple subpartitions. Inside the topic, we have a multiple subpartitions. Right? Example. Now, are we a good understanding of this complete architecture, right? Are we good to understand this complete architecture? So that is one topic. Under this topic, we have a multiple partitions. And again, one partitions we can make it out a replica. Sorry, two partitions we can make it out replicas. And again, one partitions we can make it out a leader. Like generally, topic is a harder topic. We can take the harder topic. Partition 0 is nothing but, and again partition 1, and again partition 2. Clear, right?
Yeah, it's clear. You can move ahead.
Okay, perfect. So now I need anyone of the AWS Cloud account access. I think just now I have one second, just a minute. We will get it cloud account access. Just a minute. Once again, I'm gathering the information of the cloud account access. Just a minute.
So in this architecture, one thing I have one question related to channel. So within a topic, right, you said that the partitions are like is to
Morning, others, ನಿಮ್ದು AWS cloud account access ಕೊಡ್ತೀರಾ ಒಂದು ನಿಮಿಷ ಕಳ್ಸ್ಕೊಡಿ. Sorry, I was another call. Yeah, yes, please. Yeah.
In this diagram which is shown on the screen, where is channel?
See, channels are nothing but when we create a topics, right? This partitions itself, it makes a channels. So that's what I written here, as you can see. Each topic will split into your partitions for scalability. That's one thing. And again, it is a channel. Topic is a mainly channel. In the high level, we call it this one. Broker is nothing but collection of all the things, everything. It is a Kafka server simply. Okay. Topic is a main channel. Inside this topic, we have a multiple partitions. One partition we can make it out as a leader. Other two partitions we can make it out as a replicas. Like this, we can make it out n number of replicas. For one order, like one topic. In one topic, we can make it out 10 replicas also. Oh, that's good.
And this offset 0, offset 1, offset 2, these are the one message.
Mhm. Yes, yeah.
This is passing multiple messages with the offset.
Yes, true.
What is the replication factor 3?
See, replication factor 3 in the sense like, just taking the backups there.
Okay.
Like 3 partitions, 3 replica factors, taking the backups.
Guy followed me back. I think his name is Steve.
Okay, so I need to get the headless slot indexes. Or else we can also make it out if we doesn't have a cloud access, we can also download the Docker desktop. Docker desktop in Windows. So we need to set up this one. So we can go with the microservices wise installation. Docker desktop for Windows. You can install it. I think now it is downloading. We'll wait for this. So Docker desktop wise, we can do the setup. Oh, already it is. Okay, let me check. Okay, let it be. It's installing. Let me check with this. It's still downloading. Once again. Someone is trying that AWS Cloud account, right? It is taking more time. It is taking more time. Once again, just a moment. Still, we can go with the AWS console here. Are we good to understand this Docker? Or everyone are good at understanding Dockers versus Dockers? Okay, fine. So anyway, I have a now cloud account. So here in this case, I want to show here MSK. So MSK is a fully managed, high available, secure services pro for Apache Kafka, right? So in this case, click on this. Apache Flink also it is there. Fully managed, highly available, and again secure services for Apache Flink. Anything we can use both. See, but generally we are provisioning MSK cluster. So say Amazon managed stream for Apache Kafka. Right? A fully managed, highly available, and again secure Apache Kafka services. So if you want, first we can do create your Kafka cluster in a few minutes in the cloud. This is cloud managed services. Okay. If we want, we can also do this self-managed. In the cloud, we can provision the Linux servers or Windows servers, and again we can install it over there. That is the first level. Second thing, we can use the default managed services by the cloud, and again we can create a cluster. So we can also do in the live classes, we can also do the both areas. We can also set up the Linux and again Windows, and also in the managed clusters. Then again we can create a topics, and again we can integrate applications, and again we can integrate the consumers also. Okay, create a cluster. So is it my screens are available? Is it my screens visible, everyone? Are we there? Is it moved? Hello, Dolly, Bhagwan, Joshu,
It is visible.
Bhavani, something. I think 8 of them we are. Create a cluster. So here we are going to creating cluster. So here cluster creation method, either custom create, specifically all settings include security, availability, and again custom configuration. Here use recommended best practices setting to create a cluster. Anyway, for this demo, we can do with quick create. This is a demo cluster one. Say cluster type. If it is a serverless, the backend servers are provisioned. But if it is one, provisioned servers. Like example, if the machines will be provisioning here, the backend, Linux servers or Windows servers or whatever it might be, the Apache Kafka versions, everything it will be creating. But if I want serverless, we can go with the serverless by default. Everything will be taken care by in the backend. Okay, right? So which one we want? So anyway, this is a demo class. We can go with the serverless, but in the live classes, we can go with self-hosting, that one, and also this also, both. So right now we require a high-end configuration systems, and again active cluster type, everything we should select this one. See, from the beginning, quick create, either custom create. If I do the custom create, again cluster name, provisioned, express brokers, standard brokers, how many brokers we required, like a number of zones. So basically in the cloud, we need to understand these are the regions. If you are good at in the cloud level, the regions and again availability zones we need to understand. So that's why it is telling that number of zones. How many brokers should be deployed to the each zone? This is what one of the thing. And again, brokers for zone one. See, basically in the cloud, Right now we are in Asia Mumbai. Mumbai is a availability. Mumbai is a region, and again API-1, 1A, 1B, 1C. Those are zones. So it is asking that in this region, there are 3 recommended zones are available. In each zone is nothing but data center. In each data center, how many brokers we need to deploy it. This is one thing area. This is custom create. Custom create, provisioned, express brokers or standard brokers. So standard brokers are like this. Express brokers are like this. Express brokers are like more faster, like more through output per broker, like scaling up to 20 times faster. But it is medium standard wise. So which one we need? We can choose this one. And again, this is 3.9. We can take whichever the version required. 3.9 is the latest version, and again, so 4.1 basically. But still, we can use from 3.7 to 3.6.0, 3.7, 3.8. These are the ZooKeeper. Still, it is running, but also we can remodify into the craft mode. Okay, that's one thing. But 3.9 is recommended one. And again, if you want craft or it's ZooKeeper. If you want ZooKeeper, we can use still ZooKeeper. Okay, this is a custom create mode. But we need to understand how to do this manually. Then again, we can use the cloud level. So then again, custom number of zones, 1 broker per zone. Next, cluster target, storage. Fine, we can make it out 100 GB because this is a demo lab, right? So we can make it out something 80 GB something. Okay, fine, 100 GB is fine. Cluster configurations, Amazon default configurations. This is basically custom provisioning. Cluster name, we can make it out demo MSK. Then again, finally, click next. So here we need to choose how many VPCs. VPC is something, but it is a separate network. We can choose the same network, same availability zone C, availability zone B, availability zone C. But if you know the cloud, it is easy to understand, but still choose this one. Then default security group, perfect. The port numbers. What is the port number for ZooKeeper? 2181. And again for Kafka, 9092, 9093, 90494, depending upon the brokers. Click next. So unauthenticated access or IAM role based authentication. So now I want unauthenticated access. So I don't want any kind of TLS based, either SASL based. So these are security based, but still I want unauthenticated access. No authentication is required for clients, and again, all actions are allowed. Generally, because it's a demo class, but still we can do later point how to implement this IAM role based, security based. Click next. See now Amazon CloudWatch. So these are not required. It's a exceptional. Monitoring, open monitoring with Prometheus, broker log delivery, and also cluster tags. So if you want, we can add the tags or else skip it out. That's it. See cluster name, cluster type. Kafka version is we are using 3.9, and again ZooKeeper we are using, and again broker size, machines, 1 broker for zone, and again storage 100, simple area. That's it. No need to do anything. Create a cluster. It will take some couple of minutes. So it is a creating cluster demo MSK. Anyway, it will take some time. We don't want like any auto scaling exactly. Cluster is creating. Once the cluster is created, how to connect this one, how to do this, everything, we'll see this. Okay. It will take like some 15 to 20 minutes. Still have any confusions here? How to do this setup? Very easy. and also MSK connectors, and again customized plugins. Once the cluster is created, we'll do the connectivity.
No.
Are we good to understand this? Bhavani, Bhagwan, Dolly, Lagbir, Joshu, Madhav, Rahan.
Yes, sir. And one more thing, we also do have this AWS MQ, right? So over there we do have Kinesis, we do have other services also, right? So
Yeah.
from there, so like I believe AWS Kinesis is also at the back of that is also Kafka, or is it something different?
No. See, Kafka and again ZooKeepers. See, MSK is by default AWS managed services. But Kafka, ZooKeeper, what we are doing, right? We will be doing the like our own data center. We can create our own self-owners, hosted one. But here is a completely managed services we are using.
No, over we also have this AWS MQ,
Oh yeah.
like another service which is your
No, that service is called as a simple queue services, SQS.
SQS is there.
no,
SQS.
I'm talking about that Kinesis itself.
This one.
AWS.
Simple queue services.
No,
This is
no,
only
not
what.
simple queue services. I'm not talking about simple queue. I'm talking about this Kinesis.
Yeah.
There is, if you type MQ, AWS MQ, yeah, over here it do, I believe it do have multiple active MQ. Also, it do have AWS
Rabbit
Kafka.
MQ. Yeah, these are standalone one, but it is not a distributed and again scalable one. This is the by default low latency and again low through outputs.
Okay. No, it do have option to select that thing, your Rabbit MQ, Active MQ, and also I believe Kafka or something like that. It do have that
Yeah,
option.
yeah, it is having, but it is not a distributed one.
Okay, okay.
That is the one thing. Okay, yeah. I think this it will take more than 20 minutes for this cluster creations. Anyway, let me creating. Anyway, if it is taking more time, so till tomorrow also we have a demo. So after that, we can, if all goes well, register it. Then again we can take the classes with the live more projects. Clear, Bhavani. So Bhagwan, Sarvinda, Joshua, Lagbir, Madhav.
Yeah, so I just want to know, like how many days this class will be there, and what is
This is the
the
7 weekends. 7 weekends. I mean 1.5 month. Yeah.
7 weekend, and how many projects you will be teaching, like end to end?
Yeah, I will be teaching 2 projects. One is a web application like producers we can integrate, and again consumers. So two applications is fine. Yeah.
Those two applications are Java based or Node based or something.
Yeah, we can build Node.js application and again Python Django applications to level. Yeah.
Okay, those will be microservice based architecture.
But we need to build our own applications. For that, we need one extra time. We can also build by using the AI tool. We can build our own microservices application wise. From there, how to integrate with the MSQ. I'll show that. Yeah.
Okay.
Yeah, sure. Yeah. So I think it will take more time anyway. So we'll connect tomorrow and again we'll do this activities, how to do connectivity and again how to do this everything. Okay.
I have questions like how many weekends we require to complete this course?
So maximum 7 to 8. Yeah.
14, 15 classes.
Yes. Yeah.
Okay. Thank you.
Thank you. Okay. Then again, we'll connect tomorrow. So please be available so that we can connect tomorrow. Okay. Thank you, everyone.